Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with spectroscopy for chemistry, and in this chapter I will take first of all UV spectra, and this is lecture number 20 for that. In this lecture I will explain you again electronic transition. In previous lectures also I have started this, okay, but I could not complete in one lecture. That's why I'm repeating some of the things again, but in this lecture you will find something new. First of all, we will see sigma to sigma star transition. For that, there should be single bond between two atoms of organic. Let us take carbon-carbon single bond, and there are two electrons in sigma bond. When this kind of molecule absorb ultraviolet radiations, then one of these electron absorb energy and transfer to sigma star orbital of the same molecule, and that is known as sigma to sigma star transition. Okay, in this case now carbon and carbon has only single electron, and one electron will transfer to sigma star orbital. Okay, now let us see with the diagram. These are sigma BMO and sigma ABMO orbitals of carbon. This is sigma BMO orbital, and left and right are sigma star ABMO orbitals of carbon. Now, as there is single bond between two atoms, this carbon has two electrons in sigma bond like this. Okay, so we'll put it like this. When molecule absorb radiations, ultraviolet radiations of wavelength less than 200 nanometer, then one of these electron absorb energy, the energy of electron increased, and it will move from sigma orbital to sigma star orbital. This is known as sigma to sigma star transition, and for that energy required is ultraviolet radiations having wavelength less than 200 nanometer. Now we will see that one of the electron of sigma bond will transit to sigma star orbital of carbon. Okay. So now there is only one electron over here. An excited electron would be in sigma star orbital. So this is called sigma to sigma star transition. This orbital is sigma BMO and another orbital is sigma star ABMO. So this is called sigma to sigma star transition. The energy required for this is having shorter wavelength, and this is called vacuum ultraviolet region. Okay, so when a molecule absorbs ultraviolet radiations of lower wavelength, that is less than 200 nanometer, from vacuum UV region, the electron from sigma BMO orbital is transferred to sigma star ABMO orbital. This is known as sigma to sigma star transition. Alkanes and all saturated compounds have only sigma bond, and therefore sigma to sigma star, only sigma to sigma star transition is seen in such saturated compounds. Sigma bond is strong bond, a strong covalent bond. Which requires high amount of energy for excitation. And you know that as E is equal to hc upon lambda and E is inversely proportional to wavelength, that means sigma to sigma star transition require shorter wavelength, radiation, mainly from vacuum UV region. All organic compounds have sigma bonds within atoms. Therefore, this transition, that is sigma to sigma star transition, is common for all. And we don't get proper information from this transition. Therefore, it is common practice to avoid sigma to sigma star transition. So, UV visible spectrophotometer is designed with absorption range from 200 nanometer to 800 nanometer. Thus, sigma to sigma star transition cannot be captured. So, alkanes are transparent for UV visible spectroscopy. In such case, alkanes, cycloalkanes, like normal hexane, cyclohexane, etc., can be used as solvents. And this kind of solvents will never interfere in spectra of unsaturated compounds. So this is what about sigma to sigma star transition. Thank you so much.